All right, so today we're going to talk about how to graph rational functions. Now, written this way, you can see some things about the graph, but really what we want to do is we want to find the vertical asymptote, any holes, horizontal asymptote, x-intercept, y-intercept. And so in order to do that, we want to combine this fraction, these two fractions, into one fraction. So in order to do that, we need a common denominator. Now here, I want you to write this down. If you need to pause, that's fine. But this x squared minus 2x, we have a x, which is the greatest common factor, that can be factored out. And so if we do that, what we would have left is an x times x minus 2. And so what we see is that they share, at least each denominator shares an x minus 2. But what the first one is missing is it's missing an x. So I have the x minus 2, but it's missing this x. So I need to multiply this top and bottom by this x. So meaning that its common denominator is going to be x times x minus 2. So what we see is x times 2 is just 2x over x times x minus 2, and then minus 3 over x times x minus 2. Now, from here to subtract, because we have like terms, what we're saying is that this is the same thing as saying 2x minus 3 over x times x minus 2. Now, one reason why we want to write that, one, it might be easier to put into the calculator, but if you put the original into the calculator, you would still get this graph. Two is now we can see some things. So we've talked about holes and vertical asymptotes and things like that before. A hole occurs anytime that I can simplify something out in the numerator and in the denominator. So this one, we have no holes, so it's not available. There are no holes in this graph. There was nothing that was simplified out. Now, we do have a vertical asymptote, and you can see, graphically speaking, it looks like this vertical asymptote 1 is going to be right here at 0, and then 1 looks like it's going to be right here at 2. So where we get that is by taking each factor in the denominator and setting it equal to 0 and solving. So here, if I take that, I get that x equals 0. So I have a vertical asymptote at x equals 0. I also have a vertical asymptote. If I took x minus 2, set that equal to 0, and solved by adding 2, I have another vertical asymptote at x equals positive 2. So I have two vertical asymptotes. Now, it doesn't show up on your graph, but we have this dotted line down our y-axis, and then we also have this dotted line when x equals 2. Now, meaning our graph is not going to cross a vertical asymptote, but our graph can cross a horizontal asymptote. So we have our two vertical asymptotes. Now, we don't have a y-intercept. How do we know? Because it's never going to cross the y-axis in this case, because our y-axis, this x equals 0, is a vertical asymptote. So the y-intercept is none, so not available. So there is no y-intercept. Now, where is this graph going to cross the x-axis? Well, let's take a look at that. So where it's going to cross the x-axis, what you do to figure that out, to find your x-intercept, is you take your numerator, this 2x minus 3, you set it equal to 0, and you solve. So holes and vertical asymptotes, you look at the denominator. For your x-intercepts, you look at the numerator, and you solve. So here I get that 2x equals 3, and after I divide by 2, x equals 3 over 2, or you could say x equals 1.5, right? Since we're graphing, either one of these is fine. I do want you to know that 3 over 2 is 1.5, and if you look here, our graph does cross when x is 1.5, or 1.5. So our x-intercept, we only have 1. You can write 1.5, or you can write 3 over 2. That's fine. Doesn't matter. Finally, so if I look for vertical asymptotes and holes in my denominator, and I look for x-intercepts in my numerator, then how do I figure out the horizontal asymptote? If you remember, hopefully, you compare the highest degree in the numerator compared to the highest degree in the denominator. Now, our highest degree in the numerator is a degree 1, because I have a 2x to the first power. The degree in the denominator is a 2, because x times x gets me x squared. When your degree is higher in the denominator, than it is in the numerator, this means that you have a horizontal asymptote at the line or the equation y equals 0. So we have a horizontal asymptote at y equals 0. And we see this being the x-axis, where our end points, our end behavior, is going to approach this x-axis or this line y equals 0, but it's never actually going to cross it. Now, that's end behavior. In the middle of the graph, we see obviously it is crossing that, and it crosses where? At this 1.5. So when graphing rational expressions, there's a lot that we can find, especially when we get it into one fraction. So what I would suggest is get it into one fraction, look at your denominator for any vertical asymptotes or holes, look at your numerator to figure out where it's going to cross the x-axis, look at the constant, obviously for your y-intercept, but in this case we had an asymptote at a y-intercept. And then finally, the horizontal asymptote, you're comparing the highest degree in the numerator with the highest degree in the denominator.